Hi there, this is Penelope, FS3128, Topic 6, Class 2. We're still looking under the broad heading of more functions. This time we're looking a little bit further at exponential functions that we started on in Class 2. What we're going to look at here is their graphs. As far as this course is concerned, we just need to be aware of the basic standard, if you like, y equals e to the x and y equals e to the negative x, and mostly we can sketch exponential graphs by simply comparing them with those two. The larger the coefficient, of x, the steeper the curve. So if you look in the middle diagram here where we've got a 2 and a 1 as the coefficients, the 1e to the 2x is steeper. A curve with a positive coefficient slopes up to the right, and we talk about those representing exponential growth. If it's got a negative coefficient, like the last graph on the slide, then we talk about it as being exponential decay. And it slopes downwards. So it approaches 0 as x gets larger and larger and larger. We need to be able to use this kind of thing. What we need to be able to do is to do stuff graphically that would be just too hard to do at any level probably, other than using some computer software. What we've got to do is go, okay, we want to solve e to the power of x plus x is equal to 0. What we can do is to split it up into actually two curves and find where they meet. So if we split it up into rearranging first, because that's really what we're looking for, and then say, well, let's draw y equals e to the x, and let's draw y equals the negative x. Now, I've already drawn them on here. So this is y equals negative x. This is y equals e to the power of x. And we can see where they meet there. Now, if my graph was accurate and big enough, we could be able to read off that x was equal to negative 0.57. And we know that that's true, so that y would equal 0.57. So that's the point of intersection. We're just reading it off a graph. Similarly, for the next one, we would break it into two. We would say this is the same as solving e to the x over 2 equals 2e to the negative x. And then we'd draw both of those. Which I have done, and you can see that they meet there at approximately x equals 0.46. And then we could put that in, which I haven't done, and find the value for y. Then we've found the solution to our original problem, e to the x over 2 minus 2e to the negative x equals 0. This is one of the problems. This is the graphs from the textbook. You will need to look up these. This is just here to help you with the problems that you're going to do. 19.3, also 19.3, but number 3 this time, and 19.3, number 4. So I've just drawn the graphs and put these solutions in for those for you.